Number 46. Read the labels of several commercial products and identify monoatomic ions of at least 4 transition elements contained in the products. Write the complete electron configuration of these cations. Okay, so there was a discrepancy once before in the beginning of this chapter, so I just want to say that the other textbook, just the chemistry textbook from OpenStax, they taught nomenclature before they taught electronic structure. And in this textbook, the Atom First textbook, they teach electronic structure and electron configuration before they teach nomenclature. So there really is no way that you guys would be able to, at this point, to just identify monoatomic ions and then just get the charges. So that's okay. That's why I will give you some of the monoatomic ions. So I don't expect you to know them or how to get them from looking at commercial products. So what I will say is that they want just 4 transition elements. So you guys should know where your transition elements are. They're in this category right here. So if I had to highlight them, and guys, I'm going to be using this periodic table heavily for this question. So get out a periodic table and mark it up just as much as I do, because it's much easier to see your periodic table than trying to look at this one. So all of this are transition elements. There are some exceptions, but for most part, all of these are the transition elements, all right? So we can just put transition elements. Okay. So they want you to just figure out from the commercial products to find out, what monoatomic ions they are. So I'm just going to say that, all right, I looked around and I'm going to pick iron because iron is used in a lot of tools, used in a lot of steel. I'm going to use titanium, which is over here. Titanium can be used in aircraft carriers, on planes, and also in artificial hips. So my dog has 2 hip replacements and they're both made out of titanium. So that's pretty cool. He's like bionic. We call him Tyrion Bionic, but that's okay. Another one I'm going to do is copper. So copper wire, copper steel. It's for electricity. Electrical cables are found with copper in them. And then last but not least, we'll do nickel. Nickel is found in stainless steel, so nickel would be all over your appliances, especially if you have stainless steel appliances. So I'm going to list one at a time, so it doesn't really matter. Let's do, I guess we'll go from left to right. So let's do Ti, but now we just have to give an ion. And an ion is a charged atom, I'll say. So it has to have a charge. Now these are metals, right? Transition elements, but these are metals. And metals always lose electrons. So they will always have a plus charge. And that's why they call them cations. Cations always lose electrons. So majority of the time, metals will be your cations. There will be exceptions, especially in organic chemistry. But for right now, cations lose electrons. Generally speaking, metals are the cations. So I'm just going to say that Ti was a +4. Okay, now I'm going to erase what I have here because it's going to get a little messy because I want to show you how to read the periodic table in terms of electron configuration now. So I'm going to just erase this because it could get a little hairy in here. Now, the deal with electron configuration is basically all it is just a roadmap. It's a roadmap of basically how to get to someone's quote-unquote house or home. But you got to start from the beginning and you work your way all the way to the end. And the end is always going to be the element that is stated. Now, there will be a difference because they give you a cation here. So to do these is the first thing that you do, you will write the electronic configuration for the element without the charge. So always write it for without the charge, and then once you have it, then you adjust electron configuration with correct charge. So for right now, I'm going to just forget about that titanium has a +4 charge. I'm going to write the electronic configuration for just titanium, and then you manipulate at the end. But now we have to, put the subshells in their correct order on the periodic table, and this is where marking it all up is going to help. So first off, when I look at the periodic table, I say bye-bye to helium over here, and I put it right here. It's going to be much easier for you. And plus, helium should be in the S category. It shouldn't be with the P's. And just like I said, this is the S subshell. So everything here, if I had to now color this, this will be where the S electrons are found. So the yellow for this case would be S. The P's are all of these elements. So every single electron is found in here. That's where the P's are. So if I had to highlight, I'll highlight that in green. So all of this is your P's. And now, last but not least, is the D's. That's in the section that we didn't color in before. So that's from here all the way to here. So D. And then I'll color that in blue. Now, for this case, we don't have to worry about the F's. Probably later down the road, we will have to worry about the F's, but we don't have to worry about them right now because the transition metals that I stated are not heavy enough or big enough to count the F orbitals, and the F orbitals are right here. So we don't care about them. Okay, so the most important thing that you're going to do for electron configurations is follow the atomic number. I can't stress this enough. All right, kind of like follow the yellow brick road, follow the atomic number. So just follow the atomic number. You gotta go from 1 all the way to the number that you're searching for. So titanium's atomic number, if I had to circle titanium again, titanium's over here. Titanium is a number 22. So atomic number is 22, which means that I have to start from 1, which is all the way over here. You always start with hydrogen. And you work your way down. You pass through every number. So helium is a 2. So 1, 2, 3, 4. And look at your periodic table, guys. Find those atomic numbers out. They will be the whole numbers. All right, and you got to go through all of them until you get to number 22 in titanium's case. So let's get to it. Now, one other thing that I want to say is that the S's will start with 1. So this first section here is 1S. So this one would be 2S and 3S, 4S, vice versa. Not vice versa, but so on and so forth. So the S's always start with 1. The P's will always start with 2. So this first section is a 2P. So the P's will always start with 2. So if you have to go down here, this is a 3P and 4P, etc., etc., etc. What do you think the D's will start with? This first one right here is a 3D. The D's start with 3. And then if we need to know, the F's start with 4. So they go S starts with 1, P starts with 2, D's start with 3, and the F start with 4. So let's follow the atomic number to get to titanium, which has an atomic number of 22. We're not taking into consideration the charge. We're just going to titanium. So start from the beginning. We have we have hydrogen. That's the 1S subshell. And now we have to pass both hydrogen and helium, right? I got to pass both number 1 and number 2 to get to 22. So I pass both boxes. Now, when you're doing electron configuration, don't look at all these elements. Just think of them in terms of single electrons. So every single one of these has just a dot in them. Don't necessarily think of any of the elements in here. You're just passing their homes. So you pass both boxes, so that's why there's a 2 on the top here, representing the 2 boxes that you had to pass. So now you're at number 3, and atomic number 3 is here. So that's part of the 2S category. So that's the next part. 2S You still got to get to number 22, so you have to pass 3 and 4. So that's another 2 boxes. So that would be 2s2. Now where's number 5? 5's over here. 5, 6, 7, 8, 9, 10. Those are all part of the 2p. So the next would be 2p. And if you count the boxes, there's 6 of them. So you pass all the boxes because you got to get to number 22. So you pass all the 6 boxes. So it's 6. Next, we're now at number 11. So this is 3s. So 3s, and now we have to pass both boxes because 11 and 12. So that's 3s2. Now we got to find number 13, which is here. 13 all the way to 18, that's in the 3p. And you pass all the boxes, so that's 6. Now you're down to number 19. We're almost there. We're at 22. Almost. So this would be the 4s. So this would be 4s. You have to pass both boxes, so that's a 2. And then let me move this over a little bit just so that we have a little bit more room. We're finally at the 3D, because remember, D's start with 3. How many boxes did we have to pass? 1 and 2 to finally get to 22. So you would only put 2 up top here. And that's your electron configuration for titanium before you take into consideration the charge. Now we have to take into consideration the charge. So how do we do that? How do we adjust? You always take away from highest number shell. And remember, the shell is the n number. It's the number in front. So with all of these, I scan these and I say, oh, this is the only one that has the biggest number in the front. This is the 4th shell, right? This is n equals 4. So I need to get rid of 4 electrons. There's 2 here, so this whole thing goes kibosh. I still need to get rid of 2 more, because I still need to get rid of 4 total electrons. Now your work from the back. So all of these are 3s, so you work from the back one that you just touched. So you kind of work backward to front. So in this case, there's 2 electrons here. Goodbye. So these 2 total equal 4 electrons. So your titanium 4 plus electron configuration would be 1s2, 2s2, 2p6, 3s2, and just 3p6. That's it. Box that answer off. That's the answer. So that takes care of the first one. Now we just have to do this 3 other times, but you'll get the gist. The next one that I want to do, let me just box this off. The next one that I want to do is the copper one. So copper 2 plus. So you always do the electron configuration for the element without the charge, right? Without. And then you adjust. So let's just pretend where copper is. Now we don't care about titanium anymore. We care about copper, and copper's all the way over here. So it looks like I basically have to do the same thing as titanium, right? Because I got to go from 1 all the way to at least 22, and then some. I got to go all the way to 29. So the electron configuration will always be the same for the before numbers, because you had to follow the same exact route, right? The atomic numbers are never going to change. So the route that you had to follow is going to be the same all the time, technically. So you had to start from 1, so that's 1s. You had to pass both those boxes, so 2. Then you go down to 3, that's lithium, so that's 2s, 2. Then you're over here to 5, that's 2p, and that's 6 because you had to pass all 6 boxes. Now you're at 11, that's 3s, 2, because you passed all of them. Now you're at 13, so that's 3p, 6, you passed all of them. Now you're at potassium, right? You're at number 19, so that's 4s, 2. And now you want to get over here, so you go a little bit farther than what you had here. So how many boxes do we have to pass? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be 3d9. Now we take into consideration the charge. You need to lose 2 electrons. So remember, you take away from the highest shell. It's the biggest number in the front. So here, the highest number is the 4. And look, there's 2 here, so bye-bye. You get rid of those 2. Those were the only 2 that you wanted. So now you just rewrite. You can say 1s2, 2s2, 2p6, 3s2, 3p6, and then 3d9. That's it. Let's do the nickel one, Ni2+. So we have to write the element without the charge, and then we take into consideration the charge. So nickel is literally just 1 away from copper. So it would be the same thing that we wrote, but just 1 away. Instead of 9, it would be 8. Do you guys get that? But if you have to follow the atomic number, go for it. Start with 1 and end at number 28. So it would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d, we now trying to get over here, so that's 1, 2, 3, 4, 5, 6, 7, 8. Now let's take away those 2 electrons. 2e. Take from the highest number, that's the 4. So there's 2 here. So bye-bye. The whole thing gets kiboshed. And now if I just erase this, oh gosh. Now if I just erase this, right? Because that's not longer here anymore. And we just put this next to it, that would be the configuration. And that's the answer for the nickel one. So box that answer off. And then last but not least, oops, sorry about that, guys. Last but not least, let's do Fe3+. I'll do it up here. So once again, write the configuration without the charge and then adjust for the charge. So Fe is over here. So it'll literally be the same thing, but the only difference is you're just adjusting for, it looks like 6. So it would be a D6. So we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then we have a 3d, 1, 2, 3, 4, 5, 6. We want to get rid of 3 electrons. Well, we find the highest shell, that's the 4. There's 2 here, so bye-bye. You lose 2 electrons here. We need a total of 3. So now you work from back to front. There was 6 total electrons here, so now there will only be 5 because you had to lose 1 more. So if I had to rewrite this, it would just be 1s2, 2s2, 2p6, 3s2, 3p6, and then 3d5, and that's the answer for Fe3+. Box that answer off. That's the final answer. Whew. Crazy question to do the first electron configuration. But if you guys can do this, I mean, this is as hard as it gets. So if you can do this, you are set for your test, quiz, homework, you name it. You got this, all right? So keep up the hard work. Keep studying hard. There's going to be tons more questions for electron configuration. I'm here for you guys. I'll see you guys in number 47. And if you want to subscribe and help the channel out grow, we would very much appreciate it. Right now, I think we got like 70-something subscribers. So it's pretty cool to see the number increase. And plus, you guys will get access to all of our questions that we put out. Thank you so much for that. And I will see you guys in the next question. Bye-bye.